Hello everyone, myself Aishwarya R. Today we are going to see a topics on system software and compilers. Now let us see what are the topics I will be discussing in this video. Today I am going to discuss about the Lex and Yak and the program on Lex and Yak. Now let us see Lex. Lex is basically a program which generates into lexical analyzer. The lexical analyzer is a program that transfers an input stream into a sequence of tokens. Lex refers to lexical analyzer generator tool. It's a program which converts a set of regular expression as an input and it will generate a code for a lexical analyzer or a scanner. The generated scanner is responsible for tokenizing the input stream of characters and identifying the lexical units in the source code. The Lex tool simplifies the process of building a scanner by allowing the developers to specify the regular expression that define the patterns for different tokens in the language. Now let us see the structure of Lex. Lex basically consisting of definition section, rule section and user defined section. Here you can see this is the definition section where it consisting the optional section which allows you to include a C code or the declaration section. It is known as a declaration section and also known as a definition section, where it copies directly into the generated Lexer code. It is commonly used to define the global variables or the header files. In the definition section, basically header files will be declared. Next, regular expression, rules and corresponding action. The second one, it is a rule section where regular expression, rules and corresponding actions will be performed. In this section, we can define the rules recognizing the patterns in the input stream using regular expression. Each rule is consisting of the regular expression pattern which is followed by an action in the C code, where it will be executed when the pattern is matched. The syntax for rule is pattern action. Next, and the last section in the Lex program is user-defined function. User-defined function, this is the entry point of the generated lexical code where we can initialize the code such as opening files or initializing the data structures, or then we can call from the starting process to the input, processing the input. It is important to note that the Lex is typically used in with a Yak parser generator which defines the syntax and the semantic action of a parser. Lex, it will generate a lexer that tokenizes the input of the parser generated, where in the last section the main function, the actual code will be executed, where we can initializes the values and calling the lexer. Let us see the functions of Lex. Lex consisting of tokenizing. First one. Lex is primarily used for lexical analysis which involves breaking the input source code into the meaningful units called as tokens. Lex uses a regular expression to define the patterns for recognizing the tokens into the input stream. Next, second one, pattern matching, where Lex allows to define a patterns using a regular expression where we can associate them with the specific actions. When the pattern is matched in the input, the corresponding action is executed, where we can enable you to perform the task like counting the tokens, generating the output, or building a simple table. Next, third one, generating the lexical analyzers. Lex generates a code for lexical analyzer known as a scanner based on the provided regular expressions and the associated actions. The generated code can be integrated with other components of the compiler or the interpreter. Now let us see what is YAC. YAC stands for Yet Another Compiler Compile. YAC stands for Yet Another Compiler Compile. It is a parser generator tool used to build the syntax analyzer or a parser component of a compiler or interpreter. YAC takes a formal grammar specification as an input and generates a code that can recognize and analyze the structure of the input according to the grammar. YAC, or it is an open source counterpart where it is commonly used in the development of system software to implement the parsing phases of the compiler or an interpreter. It works in the conjunction with a lexical analyzer such as a lex or a flex, which tokenizes the input stream of characters, and YAC analyzes the sequence of tokens to determine if it is conforms to be a specific grammar. Now let us see the structure of YAC. The structure of Lex and structure of YAC is very similar. The only change in the structure of YAC is here we will use a grammar, but in the structure of YAC where we use the rules. And the definition section and the user subroutines is common for both the structure of Lex and YAC. It consisting of a declaration or the definition section and the grammar, where in the structure of Lex we use a rules, and the last one is same for both the structure of YAC and the Lex user defined functions. The declarations and user defined functions are common to both Lex and YAC, but the only change or the difference is in structure of YAC we use a grammar, there we use a rules. Declaration and definition, where we can define the tokens or any other necessary constants or declaration used in the grammar. Next, grammar. A grammar where we use a context-free grammar for a language being parsed. It defines the syntax rules or the associated actions with each rule. These actions are written in the programming language where you use it for implementing the parser. Usually it will be in C or the similar language. Each rule in the grammar consisting of non-terminal symbol, a colon, and a sequence of terminal and non-terminal symbol where it is enclosed with a curly braces. The action code is executed based on the code generation. And the last section is the user defined function. User code section allows us to determine any necessary additional code where such as definitions, external libraries or the global variables required for the implementation of the parser. Now let us see the functions of YAC. Parsing. YAC is used for parsing the input tokens produced by Lex or any other lexer. It analyzes the structure of the input according to the grammar specified by the user. The grammar is defined in terms of the production rules where we can describe how the different elements of the language can be combined. Second one, generating the syntax analyzers. YAC generates a code for a syntax analyzer known as a parser based on the providing grammar. The generated code uses a technique called as parsing to build a parse tree or an abstract syntax tree. It is known as AST, representing the structure of the input code. Third one, semantic actions. YAC allows to associate the actions with each production rule in the grammar. These actions are executed when the corresponding rule is applied during the parsing. Semantic actions are typically used to build the abstract syntax tree where we can perform the type checking, generating the intermediate code, or perform other tasks related to the language semantics. Now, let us see a program on Lex and YAC. I've taken a simple program to check whether the given email is valid or not. It consisting of definition section, rule section, or grammar, or next user defined section. Definition section where we can define the tokens with any other necessary constants or declarations in the grammar, and in the grammar section where we can specify the context-free language defined by the past, where we can define the syntax-free rules and associated actions with each rule. User subroutine. User subroutine will consisting of necessary additional code where we can add an additional code such as function definition, external libraries or the global variables required for the implementation of the parser. Now let us say a definition section. In definition section, it is initializes our tokens and here consisting of int flag, where a int is a variable, int is a float integer, where float flag, int flag is initializes to 0. Then in grammar section, we are checking a valid email. So in grammar section, email may consisting of letter from A to Z, or it may also consist from numbers from 0 to 9. Plus means regular expressions 0 or more. At next, same it may consisting of A to Z. Here it is a condition given for the valid email. So next from A to Z plus means one or more .com or .in. Next this symbol represents or. Then flag is initializes to 1. Then the main function is used in while x function are also used. Then next if flag is equal to 1 then it will print accepted, else it will print not accepted. So if the flag or the given valid email is valid means it will print as accepted. If the given email matches where condition where it should be equal to 1 then it will print as accepted. The given valid it is a valid email, or else if flag is not equal to 1 if it does not matches with the email. If flag is does not equal to 1 if it does not matches with the valid email then it will print as not accepted. Now here is the output where we should use a program name with .l for a lex program and .y for a yak program after initializing both the values. Then next a.out for the output where he has given as CSC at ans at gmail.com. If it is matches then it will accept. If here it is a format of email, if it is matches then it has been accepted. Then next 123 at 33.com. Here it does not matches because the given condition it must start with from an alphabet from A to Z, next the numbers. So here it is not accepted. So only here the email matches. So only here the email matches. So only here the email matches with a given condition. With a given condition. Here it is not accepted because the email should start with the alphabets where the given condition or the regular expression is given. No, so it must start with from A to Z. Not accepted. Then next here, see here is another example where it has started with abc at def.com, abc at def.com. So here it has been started with a given condition A to Z, and then at next it has started with an alphabets, then .com. So here it is unaccepted. Thank you.